All right, let's get into this next R script and uh, let's do a two-way analysis of variance. I've already put the data up on the web page. It's already in the CSV format, so it's good to go. This is a data set that contains information on two seed varieties and then three levels of fertilizer. It's a completely balanced design. And what I've done here is I've identified the seed types as 1 and 2, and I've spelled 1 and 2 out rather than use the numbers 1 and 2. And for fertilizer, I've used low, medium, and high, or L, M, and H. So I don't now have to go back and indicate that they are factors because they're alphanumeric or alpha. They're going to be treated as factors regardless. So let's look at the R script that we have here. And you can see the first thing that I've done is typed in RM. So clear the memory, list equals ls. And then I'm using the command here, the read CSV command to get the data set in. So I'm calling the data set yield data. So I use my little arrow, read.csv, file.choose, and I indicate that there is a header. So that gives me this first row of data here, so the seed, FERT, yield. And notice that those are all capitalized. So seed is capitalized, FERT is capitalized, and then yield is capitalized. So here I've simply asked for R to print out the data set for me. I don't have to look at the structure, anything of that sort. I know it's going to be fine. I attach the data set here. Box plot yield versus seed, and that's shown over here on the right. I have another box plot which is buried behind this, and that's yield versus fertilizer, so you can look at both of those. You can click this one of these little boxes up over here, and that will then increase the size of that pane, and then you can toggle between the two box plots. So the data look okay. They're not perfectly normal, but then recall that for the most part, analysis of variance is fairly robust with regards to moderate deviations from normality. So now my analysis of variance can be done simply with the AOV, and I've got yield as a function of fertilizer, plus seed, and then I'm including the interaction term here, so plus fertilizer times seed. If I don't include that interaction term, then the degrees of freedom associated with that are going to be included in the residuals or in the error term. So that then gives me this partial table right here, which gives me the degrees of freedom and sums of squares, and that all looks good. I can then get the summary of that to get the full ANOVA table. So summary, and then the same statement that I had up here. So when I do this, I can simply highlight AOV and AOV and that, copy it, and then paste it down here inside the summary command. And when I do that, it gives me this nice little table right here. So that's exactly what I'm looking for. The degrees of freedom are distributed appropriately. The sums of squares are all correct. The mean square values are correct. And importantly, the f-tests are all correct. And you'll notice here that everything is significant. Now, just to keep in mind, once you have bigger designs, so three-way ANOVAs and four-way ANOVAs and so on, you very rapidly run out of degrees of freedom because all these degrees of freedom associated with the interaction term are taken out of the error term. So you can very quickly find yourself in a situation where you have no degrees of freedom left over for the residuals. So you have to then make a decision which interaction terms are important or biologically meaningful, and then simply don't include those in the model statement and you'll be fine. So that was quick and easy. The data are already up on the web page. The script here is on the web page as well, so you should be good to go. Very good. I will see you guys next time.